So my name is Nate, and I'm going to talk a little bit today about automation. I want to talk through some examples of different kinds of automation, both larger and more exciting, and also a little bit smaller, and talk about how these can improve our development workflows and hopefully spark some ideas and maybe some questions about what pain points in your projects can you possibly think about automating or making a little bit more developer friendly. So to start, we want to think about this question of why do we automate to begin with? And when I kind of posed this question to myself, the first thing that came to mind was, well, because we can. Like as developers, right? Like we like to tinker, we're curious, a lot of times we're lazy, but like in a really productive way where we'll spend hours trying to save minutes worth of work. So all of that's well and good, but I want to talk about a few maybe more practical reasons why we might want to automate different parts of our development flows. So the first one, and it's maybe the most important one, is that we want to be able to consistently build the right thing at the right time. We want to avoid having a bunch of local sources of truth and instead rely on our build somewhere out in the interwebs that's going to consistently always build things the same way so that we can trust that process and we don't have to start second guessing the output. Largely why we want to do some of this is because we want to then be able to save time and energy for the more interesting challenges. We don't want to be worrying about having to second guess whether or not our build artifacts are correct. Ideally, we wouldn't want to be spending our time nitpicking code styles or linting or debating best practices. We want to focus on the more interesting parts of the development experience. And a third thing that I think is a good reason to automate certain things is that it can make the project more approachable. If you jump into a new project, if that project has linting checks and code styles and is building, it's really easy to jump into that and start contributing. In a lot of ways, it helps onboard the developer without having to actually sit down and explicitly talk through some of that stuff. If you can kind of gently nudge them in the right directions through your automation, through your CI system, then that can be a little bit more enjoyable and you don't, again, have to spend as much time working on that. So, what to automate then? What types of things can we automate? What types of things should we be automating to try and reach some of these goals we talked about? And again, the first thing that comes to mind is all the things. Like we can automate pretty much anything you want to if you're willing to spend the time and effort into it. Now, whether that's a good idea or not, that's kind of up to you and how much time and effort you want to put into this stuff. But today we're going to look at kind of 4 areas of the development flow and look at some examples along each of these where we can think about how to automate different tasks. So we're going to look at actually setting up a build and kind of the general high-level overview of what that looks like and what is involved. We're going to look at how we can kind of validate different types of code quality with this build and how we can make it easier to enforce that for all of our developers on the project. Then we're going to get into a code review and how we can make the code review process more enjoyable, more efficient, and hopefully more educational as well. And then we'll look at deployment and talk a little bit about how we can automate aspects of the deployment process so that we don't have to rely on a single person, we don't have to worry about how those artifacts are being uploaded to our beta testers or to our production users. So we'll start with the automated build. And really this is the first thing that comes to mind, I think, for a lot of people when you think about, what do we want to automate in our flow? This was the first thing that a lot of people responded to when I asked the question of, what types of things do you automate? And I think one of the reasons why it's the first thing that comes to mind is because it's really at the center of a lot of stuff we do. Once you have an automated build set up, you can start to tack a lot of things on there. The build server doesn't usually care too much if you start throwing more work at it and asking it to check more things. And it doesn't complain if you start asking it to check things like code styling, which developers on your team might do. So if you're not really familiar or haven't set up kind of an automated build on your own, just want to talk a little bit about what that is. So basically we have a build server out there somewhere. These days we have a lot of options for that. And ultimately it's just going to run through a series of tasks that you will define in some type of configuration. So this might look something like we're going to assemble our APK. Maybe we're going to run our tests, or really anything else. This could be a whole slew of things, and we'll look at some of these later on. So we have a lot of options nowadays that make this very easy to set up, which is great for us. So if you're working on a small side project for fun, you don't plan to put it into production or anything, it's still really easy and can be beneficial to go ahead and set this up, and you can do it for free usually. So a few examples of services that can help us with this is Circle CI, Bitrise. If you're working in Flutter, maybe you're using CodeMagic. But all of these offer very similar feature sets. They all have pricing models that are a little bit different, but most of them are free at kind of that low base tier, especially for open source projects. And again, the configurability of all these is going to be different. There's going to be different hurdles to jump through, but roughly you're going to be defining the same thing. So you're going to be defining like your environment, what steps you want to do, what artifacts you want to collect, and maybe where to put those. So we're going to walk through kind of the high-level example of what this might look like using Circle CI. You can maybe think of this as like a pseudo build. It's not maybe the exact steps, but we can walk through. So this screenshot right here, if you have a project on GitHub these days, I checked this yesterday, I think, and you open up a PR, it'll actually give you this little message saying, hey, we noticed this isn't being built. Do you want us to kind of help you out with that? And so if you're kind of new to this, you can click in and it'll actually give you a few examples of different services that you could go look at setting up for your project. And if you click into these, they'll jump you right to some of the setup process. So in this case, like I said, we'll look at Circle CI. So basically, this is an example config file that's required to set up your automated build on using Circle. So you have to put it at this specific directory path there in your project. And then once you set that up, and once you set up your sort of account with Circle, you can basically click Start Building. And now every time you push a commit or you open up a pull request, your project is going to start automatically building whatever tasks it has. So in this case, the only task we have there is that bottom run task. And we're just going to run our Gradle command with the assemble task. And so that's going to assemble our app. And that's it. Really, at that point, we'll start seeing these build messages every time we make changes to the code. And what's more is now when you open up your pull request within GitHub, you'll start seeing the little status messages. So you'll notice that we have the little green check mark there indicating that, hey, this build was successful. And conversely, if for some reason your build is not successful, if the code's not compiling, tests are not passing, you'll get the little X there saying, hey, something's wrong, you need to probably fix me. Now, we'll notice one little thing with this. Might be hard to tell in the screenshot, but even though the build is broken in this case, you could still merge this PR, which maybe you're okay with if it's a small personal project, but if you're working with a team or maybe something open source, you probably don't want to let people check in code that you know is broken. So you might want to go into your project settings and update this so that it requires status checks from whatever build server so that you can prevent people from merging code that you know is broken. So once you do that, again, probably hard to see, but the merge pull request is now disabled. So now we actually can't allow people to merge that code if we know it's broken, which means that we can now have some faith and reliability that our Circle build is building things correctly and going to do it the same way every time. So we now have an automated build setup. It's kind of a small step, and like in this case, we really weren't doing much interesting with it other than running that assemble task. But conceptually, this is a large step forward. We've gone from having our local source of truth on our machine to having a single source of truth that anybody on the project can now refer to. So that avoids the case of, oh, it builds on my machine, yours is wrong, we're going to ship what I have. We don't want to be doing that. We want to be able to have consistent results for everybody. So that's kind of our first step. Now we want to start talking about how we can do more interesting things with this build. How can we leverage it to give us more context and help really enforce better quality code? So this could take a number of different forms. It could be running Android lint. It could be doing code formatting checks. You could be running a tool like detect and looking for different code smells. We have a lot of options here, but really they're all going to be configured in pretty similar ways. So we're going to look at how we could enforce some code quality by running through how to set up kt-lint as an automated task as part of our build. So the first thing we want to do, assuming that you have kt-lint already set up for your project, is we're going to add another task to our circle config file. That task is going to run the kt-lint check task. So that's going to generate our output. And if that fails, that's going to send a failure status back to our build. So now, like in this case, if I push a commit where I know that I broke the formatting, we now see that the build is broken. This is really useful to us because now we're able to enforce additional things beyond just did our project build successfully. We can now verify that it's building in the right way with the right patterns and conventions. There's a small problem with this though, in that if you look at this issue right here, we see that we have the X, but we don't necessarily know what failed here. We just see something failed, which is okay, but you're probably going to want to know what's failing so you can go fix it. Now, in the way it is right now, you'd probably have to click into that details, which in this case will jump you into Circle CI, and you can see the specific task that has failed, and you can go fix it. So that's workable, but it's not really ideal, especially if you're doing this, if you're pushing a lot of code throughout the day, you have a lot of people on your team. Not everyone's probably going to want to make those extra clicks through to figure out what's wrong. And what you don't want to do is start frustrating developers on your team. You want to make sure that the build process and the code review process is enjoyable and low friction so that people actually embrace it and think it's a good thing. And so I call this out because we will look later at how we can actually really improve this process. And so you just want to hold on to that for a few minutes here. So there's another problem in this, in that we have this building on our CI. It's out in the interwebs somewhere, and it's going to fail if it's not formatted correctly. Well, let's say we're coding along, we're kind of in the zone, maybe we have a nice coffee buzz going. We commit, we push, we're excited to finish out this task and merge it. We go to grab another cup of coffee, expecting to come back, and our build is successful, so we can move on to our next task. And then we find, oh, the build is broken because I added a semicolon accidentally, or I forgot a space somewhere. This is super frustrating. It's really, really hard for at least me personally to push something up and then have it fail after 10 minutes, 15 minutes, however long your build is, and have it fail just because of something like code formatting because you forgot to check it. So how can we kind of enforce these checks locally so that we don't start wasting time in the build for things that we can validate easily ourselves? Well, the very simple answer in this case is, well, we have the kt-lint check command that we're running on the CI. We can run that locally, which is completely true, and that's what we would likely want to do. However, again, we kind of have the same issue here, right? We're thinking about maybe our next task later in the afternoon. Maybe we're thinking about Game of Thrones or trying to avoid Avenger spoilers online. We have a lot going on, and we might not remember to run this. However, we could use something like a Git hook to actually automatically remind us and run these checks for us so that we don't kind of shoot ourselves in the foot by pushing code that we could have validated beforehand. Now, if you're not familiar with what Git hooks are, they're essentially just scripts that you can run in response to different Git actions. So that could be a commit, a push, a pull. So in this case, we're going to take a look at how we could set up a pre-push commit hook, or excuse me, a pre-push Git hook to check our formatting for us. Now, there's a really great blog post that walks you through exactly how to do this, so I'm going to brush over a few of the details here on the specifics, and I have a link to this at the end if you want to take a picture or something. But basically, the first thing we need to do is to define the script itself. So in this case, we can define a script called pre-push, and essentially it's a shell script. However, it has to be at this specific directory, which is .git/hooks, and it has to not have the extension on it. So that's problematic in two ways. One is just that we want to be able to define this, run it, test it, but then we also want to be able to kind of check this in and share it with our teammates, which you can't do because it lives in the .git directory. So while adding this at this location on our local machine will help us, it doesn't help anyone else on your team. Now, whether or not you want to enforce this for your whole team is probably a team decision, but if you wanted to go that route and share this, you could do that very simply by first adding this file somewhere else in a different directory. So in this sample project I put it in a scripts directory. And you'll notice that in this case, we do have the .sh because we want to just be able to easily run that and validate that locally. Then, in this example, I actually use some custom Gradle tasks that basically grab that file from the scripts folder, copy it over into the correct Git directory, and remove that file extension. So it basically takes the file from the location we have so that we can share it, moves it over in the place where it's actually useful. So now this is great because now we can share that, and all we have to do is to remember to kind of run that task once. However, we can take it a step further, and if you really wanted to fully automate this, you could actually then hook those tasks for copying that over into an existing task like clean or assemble, something that's going to be run often to really enforce that those are going to be copied over correctly. And then once you do that, if you try to push your code, it will run kt-lint check, and then if it fails, it's going to give you a warning message instead of sending the code up to the build where you then have to maybe wait 10, 15 minutes to find out that it failed. So this can actually really save you a lot of time and hassle by helping you remember to run these checks. Okay, so to the code review point. So at this point, we've set up our build. We are now validating code quality things like code formatting, Android lint. We're confident in our code, it's passing these checks, we want to push it up, and we want to get into that process of actually reviewing this code and discussing it with our team. And now hopefully this is an enjoyable process for the team, and we're going to look at a couple tasks here that I think that you can automate to make it more enjoyable, lower friction, and help free up time for the more interesting aspects of the code review process. So first off, what kind of things do we want to focus on for code review? Well, we want to validate the changes. We want to maybe discuss the high-level approaches or patterns. And then it's also a great opportunity to learn. You can learn a lot of stuff through code review if you're putting the time and energy into trying to learn or trying to explain things and trying to foster a discussion around these changes as opposed to just trying to get them merged in as quickly as possible so you can move on with your day. So one way that I think we can start to smooth this process and help save energy for the interesting aspects of code review is by setting up PR templates in your project. This is just one of those little small nudges that I think can actually have a larger compound impact on the project. So what we want to do is avoid something like this, where you submit a PR or someone else submits a PR and there's just no context to it. Like in this message we say update the brushes, but we don't know which brushes are being updated, we don't know what that looks like, we don't know if there's an associated issue, like what the acceptance criteria are. we have no idea what this is. This is not a good way to start off the code review process. Especially if you're already having a little bit of a frustrating day and you get a PR like this assigned to you, it's probably not going to put you in a good mood because now you have to spend time and energy into figuring out what it is you're really supposed to be reviewing and whether or not it actually works. What we want to do is try and provide more context up front. So in this example here, we have a lot more information. We know much more about what we're trying to validate. And from this, we can actually start to have a real discussion. Like, we know what we're looking for, so we can start to go into the code, and then we might be able to start picking out more interesting questions or get to those, approaches and patterns and library discussions more quickly. And if we can do it more quickly, we're probably going to be in a better mood about it. So to set up something like this, we can add a markdown. That is way at the bottom, I'm sorry. It's a .github/pull request template. But basically, you can define this markdown file at a specific location within your repository. And it's just a simple GitHub markdown. So in this case, we're adding a number of sections for the related to-do or ticket. Maybe you have some high-level bullet points of the changes, any additional context. Maybe this had an associated back-end change that you just want to make them aware of. You can also add checklists that are actually interactable and will actually display in the pull request view so you can track progress through these. And then also in this case, maybe you want to suggest that the author of this pull request add things like screenshots so you know what this thing looked like before, what it looks like now. This is actually the pull request template that we recently added to a project at PicSite. So we've been using this, and it definitely has helped to sort of give that initial context in the pull review. And so now, once you have that template in place, when you create a new pull request, it'll be pre-populated with this. And so the reason I think this is useful is because now we automatically don't have to think about, what types of things do I need to add in this? We can sort of like gently nudge the developers on our team into saying like, hey, have you thought about tests? Have you thought about translations? Are there screenshots or the UI updates? And so by doing this, it kind of gets us from, all right, what do I need to add to the PR to actually filling it out quicker. It can then help remind us of those things that we might forget about otherwise. And again, I think this fosters a process where we can actually enjoy and get a lot of value out of a reviewing code. Another little quick bonus tip here, if you're not super familiar with GitHub issues, this is really small but actually really useful that if you have an issue in GitHub, you can reference it from a commit or a pull request, and if you prefix it with these keywords like closes, fixes, resolves, there's some other variations of those. When that pull request is actually closed, it'll automatically close out the issue, which I think is really useful. It's really nice being able to just reference those directly in your commit messages, especially if you know you're working on a specific task. And if you have a project set up in GitHub with maybe an automated Kanban board, you can do even more with this, but had to cut that for time. So now we're kind of to the most exciting part, at least for me. This is the thing that I think is really, really cool. And that is using Danger to sort of superpower our PRs. Now, if you're wondering what Danger is, hopefully you know in a life sense, but in a coding sense, Danger is basically just a service that we can kind of attach and include in our builds that allows us to automate a lot of these sort of more boring, tedious aspects of code review. But in doing so, that can actually give us a lot of value because now we don't have to do those. And if they're too tedious, then we are probably either going to just skip them altogether, or we're going to do them and then not have the time or the energy or the desire to put as much effort into the other aspects. So I think this is really cool. And sort of with Danger, we can start to think about a lot of things. Like we could use Danger to help remind us that we have dependencies that need updated. We could use it to track our APK size. My favorite thing is that we can use it to give inline comments on like linting or code formatting issues, which means you don't have to do that whole click multiple levels deep to see the log of which formatting issues you need to go fix. So there's a lot of stuff you can do here. And it's really pretty simple to set up. There's a couple flavors. The flavor that I'm familiar with and that I set up in this sample repo for this talk is basically using Ruby. So kind of just like the quick high-level steps for how to set this up is you need to have a gem file in your project, and then you need to add the danger gem to that file. And then once you install that, you can run this bundle exec danger init, and this will actually take you through the command line interface, and it'll walk you through all the steps for how to start integrating danger for your project. It's pretty easy to do. I think I set it up in like 20, 30 minutes or something for this very simple demo application. And once you go through that, the key piece is that you're going to end up with a danger file. Now, the danger file is where you're going to configure what types of checks and messages that you want to include in this step of your build process. So in this example danger file here, the first item is basically saying that if you have WIP included in your title, it's going to put a message that says, hey, like you said that this is a work in progress, like maybe do we really need to have this PR open right now? The last one there is really small, and it's simply just going to print out a message that says thanks to whichever user authored this pull request, which again is super tiny, and we'll get into more interesting examples. But I actually think this is like another thing where, like, especially if you're working on an open source project, it can be nice to sort of just start the process off with a little bit of like kindness or friendly face, a smiley face or something, just something to set you off on the right foot before you possibly add hundreds of comments about all the stuff you need to change. So let's talk about some of the cool things we can do with this. So I mentioned we could look at APK size. So this is a step that I borrowed from our danger file on our PixSite project. And basically all this is doing is looking at the APK that was generated from our earlier build steps, and then just analyzing the size of that, and then printing that message out to the pull request. So you can see here, maybe you can't because I'm right in the way, but you can see right here that it's now saying like the size of this APK is, in this case, 2.3 megabytes, a very small sample project. But by doing this, it makes you aware of what that is. So maybe if you have a PR that has a whole bunch of assets added to it, you might notice, oh, all of a sudden this has jumped up by several megabytes. Maybe we need to go take a look at these images and whether or not they're optimized properly. And now you can actually take this a step further, something I haven't done yet, but there's a blog post out there how to do it. But you could actually compare this current APK size to maybe your last successfully built artifact. And you could compare those, and you could maybe give a more stern warning if the APK size changes by a certain percentage. So you can really start to do a lot with that. Another interesting thing we could do here, again with the idea of trying to have more context around what this PR is about, but we could look at the actual like message in the description. And so in this case, we say if the body of this PR is too short, print out some kind of message, maybe saying, hey, we would like more context to this. So that's what this example is. You should provide a summary of the pull request, and that could gently nudge them towards, hey, this is our process, this is what we want to do when we create a new pull request. So now, here's a little bit more interesting case. So we are using a plugin that we can use to basically determine which dependencies have new versions available. So in this case, we have this step in our danger file that basically looks at that output file and then just counts up the lines and basically determines how many dependencies do we have with updates. And then if it's less than 10, I believe in this case, it'll actually print out the specific dependencies that need updating. And if it's more than that, then it just kind of lumps them all together and says, hey, you have X number of dependencies that need updating. So that looks like this. So in this instance, in this project, there was 15 dependencies with new milestones, which is slightly surprising since this was just like the stock, brand new Android Studio project. But so in this case, you can see, okay, I have this many things. If that starts to get too big, you might start feeling harder and harder, like you can keep ignoring that. Maybe you need to take the time and go and update those dependencies. All right, so we talked a lot about KT-lint earlier, and largely because it kind of mirrors other things like Android lint. And the coolest thing for me, I think, is that you can go through and add like these inline comments so that you know exactly where linting issues or styling issues need to be addressed. This is also kind of the first task we talked about that requires more than just sort of the stock danger. So there's actually a lot of additional sort of plugins that we can add to this to work with other types of output or processes. So in this case, we can add a gem that knows how to work with a check style output and then turn those into inline comments. And then we can add to our danger file these two lines at the bottom and basically point that report to a specific file path. So in this case, I'm pointing it to the kt-lint main source set check. That is a long name. But basically pointing it to the output of the kt-lint task. It's then able to parse through that output of all the formatting errors in your code and turn those into inline comments directly in the PR. This is awesome, at least I think so, because you now see specifically where all these issues are. You can address them one by one. You don't have to leave the pull request. You can do it all inline and resolve them all inline, which I think is a huge time saver. Associated with this is you might have a project that you're running, let's say, AndroLint or kt-lint, and you might have a baseline that is non-zero. I think that's pretty common. We don't have all the issues fixed. Now, we can run that and see all of those issues, but when we're running these checks for danger, we don't want to report issues that aren't within the scope of this current pull request diff. Like, we don't want to have it report out 1,000 linting errors if you changed one single file. So by adding this line, which is just dismiss out of range messages, we can tell it to basically ignore anything that's not within the explicit scope of this PR, which is very useful. All right, so that was a few examples of what we can do with danger. But like I said, honestly, you can do a lot. I feel like the sky is kind of the limit, just whatever you want to automate. Some other things that you could certainly do would be like automating the AndroLint inline messages. I'm really interested in trying to create some type of check to remind us if we have changed a strings file but didn't add any translations to it. Maybe looking at the APK size changes or changes in test coverage. You can do a lot of things here. And if you're interested or you think it'd be useful, I'd encourage you to check it out and play around. So kind of the last major section here that I want to just dive into is deployment. So we've gone through all this stuff. We're automatically building our project. We're checking the quality. Hopefully we are enjoying the code review process, getting some useful discussion out of that. It's time to ship and test our new code. How do we go about that? Well, there's a few different ways you could think about kind of when you're going to do this. You could do it daily. You could do this once a week, twice a week at scheduled times. You could have a build that is triggered and deployed in response to maybe adding a Git tag or merging it into a specific branch. Or you could do it kind of ad hoc, and just whenever you feel like putting out a release, someone kicks off a build and manually uploads all those artifacts. And honestly, for your projects, you might want the capability of some combination of these. But in this case, we're going to talk about how you can customize this sort of on a per branch basis. So this is what we have set up on our project at PixSite. Basically, if we merge into the develop branch, we have tasks associated with our build that will then automatically distribute that test build using beta by Crashalytics. And similarly, if we merge into master, that deployment process of uploading to the Play Store, as well as updating any like store listing artifacts, is also all automated. So all it takes for us to ship a test build or production build to their respective destinations is to merge code into the specific branch. So in the case of the test build, this is our build task. This is not Circle, so it might look a little bit different, but basically we see that we are saying for branch, develop, run the Crashalytics upload distribution debug task. And so basically what that task does is automatically sends that generated APK to our beta by Crashalytics instance, so then our testers can pull out the beta app on their phone and automatically see that new artifact. Now there's a little additional piece of automation here in that the release notes that are associated with that APK are also automated. So in this case, it's pretty straightforward. It just goes through and looks at kind of the log output from master to this current developed commit, adds those into a file, and then uploads that. So again, when someone pulls up the beta app, they can actually see what the commits were, and we can say, hey, I just pushed these changes for the new brush layout, and they can sort of see those related commits in there, assuming that you are taking care to actually have useful, clear, clean Git history. Now on the flip side, we have the release build. So in this case, we have a 4-branch master. We are running the publish release APK task. This is a task coming from this is coming from the Gradle Play Publisher plugin, which is really great. It allows us to sort of automate this process. It also allows us to store sort of these release artifacts, not the APK, but the actual descriptions, the contact information, all this other stuff that might change in your store listing. It allows us to treat these as part of the project so you can track changes to them. And it also means that it's very easy for anybody on the team to come in and modify those, merge into master, and then upload that new release. It kind of helps avoid this instance of, oh, I've never really released before. I don't know which fields I need to update in the play console. It sort of puts everybody on even footing to be able to understand and ship a release within Android Studio, which presumably everyone on their team is probably comfortable with. Sorry, couldn't read my notes here. So that's kind of it for the high-level things I want to talk about. So we looked at how to kind of set up or start thinking about why we want to create a build, the types of things we can enforce in that to help ensure that we're building quality code every time. We looked at the review process and how we can hopefully reduce the friction there and make it more enjoyable and hopefully get more value out of it. And then we looked at how we could start to automate our deployment processes by scripting out these tools, sending things to testers or release depending on branches and things like that. So I think kind of in closing here, the thought I want to leave with is that if you're losing time or energy or joy because of some type of task, maybe think about ways you could automate it. Is there a way that you could make this a little bit easier, reducing clicks, making it easier for others to understand, what is expected or how to do something? All of these things, whether they're really big or really small, can add up in the long run and start to have a big impact on your project. So for resources here, I have this project here on my GitHub that basically has all the steps we walked through except the last deployment process. I just ran out of time this week to put that together. But you could look at it as examples of automating kind of the Circle CI configuration, running KT-lint, the danger setup, all of that stuff is there. So a lot of links here, and I will send out these slides too, so if you don't get a good shot here or something that's hard to read, you can find them. But there's a lot of useful articles on how to set this stuff up. Not all of them are specific to the same type of platform. So some of the articles might be for Bitrise. I was looking at Circle CI. So the general steps are there, but you might have to figure some of that stuff out yourself. I want to give some special thanks here. So Ryan, because he set up so much of that stuff in the PixSite project that I just got to sort of copy into my slides and then talk about and explain away. I didn't have to do the hard work. Joe Birch, who has a great couple of blog posts and a video about how you can work with Danger and getting that set up with Bitrise. Then Sebastiano, who I followed sort of his blog post very closely for setting up the Git hooks. All of that was super helpful. And then also just want to thank PixSite both for sponsoring the conference and for being cool with me skipping out on work at the last minute and coming to speak with all of you. So thank you. If Yeah, I'll be right